Please welcome Vice President and Chief Technology Officer, Amazon.com, Dr. Werner Vogels.
Good morning, Santa Clara. Really? Come on. Shake to the left, to the right, meet the people next to you. No, I won't do that to you. Good morning. As always, we're very proud that so many of you are willing to come out here today to listen to where we are with the Amazon Web Services. As pioneers in the whole cloud world, we've developed so many services over time where each of you sort of should have the right tools to build the applications that you want to build. Something that we've always said is that we couldn't have come here without you, meaning that your feedback to us and working very closely with you, our customers, to actually build our services and to develop our roadmap is unique. About 95% of the features and services that we've delivered until now have come in direct feedback from you. And it's most important because I think if we would have been building the tools for development as old companies would have done that, we would have built the tools that you were using 5 years ago. And it's not. We want to build together with you the tools that you need to be ready for 2025. And that needs to go in lockstep because the development is changing, is radically changing, both the ways in which we architect, the operational models, the security postures, the way we use data, all these things are changing radically. And as such, we really rely on you and working closely together with you to actually build a roadmap for, let's say, the true modern application development. And so after spending a little bit of time on the business update, I'll go deeper into sort of the patterns that we've seen arriving with most of our customers and what is sort of modern development and what are the kind of things that we've built to help you build really true modern applications. So 6,500 of you are out here. Thank you very much. I think you all have busy days, and as such, it's pretty humbling that so many of you come out here to listen to us. As always, I consider these events to be educational events and not sales events. That's not why we're here. Those well over 50 deep dive technical sessions is really the meat of this gathering, where you can really get the lowdown, really all the details on whatever pieces of AWS you're most interested in. Of course, our partner network is continuing to grow. And if you go out into the expo hall, you'll find many of our partners having their stands there. Go talk to them, go hang out with them, go listen what kind of pieces they've developed for AWS. I've always said that AWS is so much more than just AWS. Without all our partners that are building, whether it's operational tools or whether it's ISVs or software, all of them extend AWS in a manner that makes it extremely rich. And whether you're integrating Twilio into your application or Stripe or any of the other partners that we have, that really makes the AWS platform so much more richer than all these services that we've built ourselves already. So let's take a quick look at where we are with the business. At this moment, based on the fourth quarter results from last year, we're at a close to $30 billion run rate. And on that base, a 45% growth year over year is pretty astonishing. And if I look at sort of the past 13 years of AWS, I think it is the speed at which we've grown has really been the biggest challenging thing. We're continuously changing IT landscape and working together with you to really grow really fast, build really the tools that you need. I think this 45% growth year over year also shows that we are doing the right thing. By working closely together with you, building a set of tools that you really can use to build your next generation applications. We're very fortunate that this has resulted in literally millions of businesses running on AWS. And an active customer is something we consider to be a non-Amazon entity. that has been active in the past 30 days. Literally millions of businesses running on AWS. And whether that is startups, and actually I find startups to be a bit of a misnomer these days, because many of these names on this slide here are household names. I mean, whether it's Lyft, or whether it's Uber, or whether it is Dropbox, or whether it's Airbnb, or whether it's Slack, or Pinterest. Maybe these companies were at one moment a startup, but in my eyes, what I would rather call them is internet-scale companies that are really focused on being internet first. Whether Lyft is going all in on AWS, Robin Hood, from the neighborhood, actually is building this mobile application for trading. 5 markets around here. They build a highly scalable analytics platform on AWS that allowed them to go from 0 to 100 million revenue in just over 14 months. And of course, it's not just the startups. Maybe in the earlier days, this was sort of the idea behind AWS to really serve these companies that wanted to reach internet scale. But I think enterprises have figured out that this is way too good for them as well. And very closely working with them, building a whole new set of capabilities. Expedia is moving all into AWS. Capital One built a digital leading banking platform on AWS. And today was a great announcement. Standard Bank, one of the largest lenders in Africa, is moving all of their infrastructure over to AWS. And another announcement today was that Volkswagen is collaborating with AWS to build an industrial platform for managing the efficiency in all of their plants. And as you can see, it's a wide variety of enterprises making use of AWS. There's almost not a vertical where there's not companies that have decided to go all in onto AWS. And whether it is enterprises, but of course also in the public sector. Thousands of agencies around the world making use of AWS, because for most of the governments, every dollar or every euro you can save actually is money that you can put towards programs that really matter for your citizens. And so whether there's, for example, the UK Ministry of Justice, who have built a whole pipeline of services that help law enforcement and prisons and all sorts of other activities around there that have very high sensitivity in terms of privacy and security. The City of Los Angeles built a whole security system in and around all of the city's departments in gathering their data and analyzing for security risks. And so across the board, non-profit organizations as well as government agencies making use of AWS. We couldn't do that without our partners, and especially I think in the enterprise world, many of these organizations already existed for a long time, these global system integrators like Accenture and Capgemini and others, but also newborn in the cloud system integrators like SecondWatch. And so many of them are the ones that are actually really helping our customers move on to AWS, especially those that have, for example, challenging environments, for example, based on SAP and things like that. And most of these partners have great competencies in actually helping you get there. If you're an ISV or a software as a service vendor, you're on AWS. Why? Because your customers are there. And your customers will demand that you're there. Most of these ISVs have been moving to a software as a service model in terms of delivery. And whether it's Acquia, or it's Adobe, or it's Info, or Informatica, or Salesforce, or Workday, Splunk, all of them have moved to a software as a service model to deliver their functionality on top of AWS. Now, I'm always fortunate in these events to have great guest speakers. And so our first speaker is actually transforming his company into a cloud-first business. So F5, which is a provider in application and security services, began working with AWS about 6 years ago. And using the marketplace and becoming a network and security APN partner competency. And so since joining F5 as president and CEO in 2017, François Leloc-Duno has focused on accelerating this effort from moving from the traditional company that they were into a solutions and services company delivered through the cloud. Now, To hear more about this, I'd like to welcome Francois to stage. Francois.
Thank you, Werner. Thanks for having me. Well, I would like to begin my story today by what most would assume is the end: success. I believe that success can kill a company. The classic definition of success assumes that we have reached the highest of heights, and that therefore what we have accomplished must be protected. That is a mindset that leads us to a very dangerous place that I call the status quo. The status quo is, in fact, the biggest threat to our companies, to our cultures, to our personal growth, because it is a familiar friend who is hard to resist and even harder to say goodbye to. So I want to share with you some of the symptoms that you see in an organization that is under the spell of the status quo. Comfortable bureaucracy settles in. You accept that it takes a long time to do anything. Your customers warn you that things are changing, but they continue to buy for the time being. And a form of institutional arrogance sets in, where how we do things takes over, becomes more important than curiosity and invention. And while these are signs of the status quo in an organization, I believe that there is one fundamental quality that holds any of us apart from succumbing to the status quo. It's a quality that no money can buy. You either have it or you don't. And that quality is the drive to reimagine. It's the belief that your first success cannot be your last. It's the courage to challenge our own formula for success because we know it can be done better. And so I am here today to tell you the story of F5's rejection of the status quo, a feat we have undertaken more than once in our history, and what it took for us to reimagine again. Now, for F5 over the last 10 years, the status quo looked like this. It was a company famous for its load balancers, but also obsessed with a hardware business model. It was us offering application security and delivery services to the top mission-critical workloads in a data center, but leaving tens of millions of other workloads unattended. It was a loyal base of NetOps users inside 25,000 enterprise customers, but very little to offer to the growing DevOps communities inside the same organizations. Now, as they say, what got us here won't get us there. At F5, we have a mission. We want to provide enterprise-grade application services for every app, anywhere. And the only way to get there is through the cloud. Now, as it does for you, the cloud requires a continuous transformation of our business. For F5, that meant significant, important, but painful decisions. We had to completely redefine our customer personas, who we aim to serve and how. We had to make significant shift in where and how we invest our resources and relook at the behaviors we promote in our own organization. And we also had to create startups, carve out startups from within F5 with a very clear new charter to disrupt the status quo. The result of this is an F5 that is now offering easy-to-consume, friction-free application services, consistent application security for every workload across every environment, and a company that is finally bridging the divide between NetOps and DevOps. By joining forces with NGINX, the leading open source application delivery platform, we can now offer enough effective controls to satisfy the CIO, but also enough freedom to innovate for application developers. And it should be no surprise that for a company committed to disrupting its own status quo, F5 chose AWS. We built our cloud services platform leveraging the breadth and depth of AWS infrastructure services. We do storage and compute, of course, but also caching and identity, database, and even serverless. We worked with the AWS SaaS Factory team to transform our own development process and build and deliver new services 50% faster. We also leveraged the AWS Marketplace. It allowed us to build digital procurement on a global basis to companies ranging from startups to Fortune 500 to our own channel partners, 12 months faster. I'll say that again, 12 months faster than we would have on our own. And leveraging the built-in metering features and digital commerce enabled by the AWS Marketplace, millions of F5 customers can now try and subscribe to F5 services in minutes. The result of this work is the next critical step in our reinvention, F5 Cloud Services. I am pleased to announce that we are launching today on AWS F5 Cloud Services. F5 Cloud Services is a family of cloud-native SaaS solutions designed for enhanced application delivery, security, and insight. And it's immediately available for our customers and through our channel partners on the AWS Marketplace. It starts with our DNS cloud service and a preview of our global server load balancing service, available for use in AWS or in hybrid cloud environments. And later this spring, we will be delivering even more F5 enterprise-grade SaaS capabilities, including security services designed to protect applications from both existing threats and emerging threats. Thank you. Thank you. There must be somebody from F5 in the room here. The best part about all this, though, is we are just getting started. I don't believe we find an end point in success. The spirit of the summit, each of us is asked to consider, what can we do differently? And I know this inspection can be painful, but I can also share with you what it feels like when you have rejected the status quo. You are restless for more. The risk-taking feels less risky. And new ideas are courageously surfaced every day. I know that is what it feels like at F5 now. And the opportunity for all of us here today to invent, to grow, and to break away from the status quo. Thank you.
Thank you, Francois. And yeah, That's why we built AWS, to help everybody break the status quo. Yeah, because in the status quo, your vendors were in charge, not you. And one of the biggest things that we tried to do when we built AWS is to take one of the pieces of the motto of Amazon, the retailer, to be the Earth's most customer-centric company. So how do you do that as an IT provider? How do you become the world's best customer-centric IT provider? It's by putting your customers in charge. You're in charge of our roadmap, but also the economic models that we put in place. We're really there to put you in control instead of us as a provider. And so our goal will continue to be the Earth's most customer-centric IT provider. To do that, we need to move away from the models that we had in the past, where we as a technology provider would give you everything in the kitchen sink and tell you, and this is how you shall use it. No. I think in a new world, everybody knows that you need different tools for the different jobs. And as such, we've been really focusing on making sure that you have choice and building the broadest and deepest platform for you as builders today, so that you can pick exactly those tools you want to build. Yeah, maybe in the past when you were building a house, it was sort of a prefab thing, and it was sit there, and you couldn't do anything about it. Maybe there's 2 or 3 of these houses that you could choose from. But if you really want to build unique houses, you need to have unique tools to really build exactly the house that you want to have. And I think that's really where we are today. So well over, I think, 165 different services in AWS right now. And that's continuously growing. And whether that is in analytics or IoT or machine learning or mobile services or the blockchain technology or DevOps, the days from when AWS was just infrastructure as a service, compute storage, databases, security, those days are long gone. Mostly because you've been asking us, once we solved, let's say, the heavy lifting in the infrastructure, to start solving the heavy lifting, the other pieces of heavy lifting that you still had. And that's why we continue to roll out these new services based on your feedback, what you need. And let's pick on a few of these. If you look at databases, we have 14 different database services. And so, of course, relational still plays a quite important role because many of you actually have real needs for relational databases, but sometimes also you're using standard off-the-shelf packages that only run if you have really a relational database backing it up. And so, but what we see more and more, and especially if we move to microservices, where the components become much smaller, and they really make use of purpose-built databases to meet exactly the needs of their application. And whether that is key value, or whether that is graphs, or whether it's a ledger, all of them have unique capabilities that we're using today. Instead of using the relational database as a hammer that you can use for everything, we are now moving to really specific, high-performance, highly reliable, managed, purpose-built databases. The same goes for security. Security, 116 of our services have encryption enabled in them. 52 of them, you can bring your own keys. And I'll be talking more about it later with respect in terms of security, but encryption is becoming the most important tool you have to make sure that you're the only one who has access to your data and nobody else. And whether that is also in combination with all the compliances and all the certifications that we've achieved, or all the innovation that we're doing under the covers to build new automation tools for you where you can actually protect yourself. Now, I think automation in security plays a very important role, and we'll get more into that in a bit later. The same goes to storage. It's not enough to just have a volume service, or a block service. You need to have different variations in there because all of you have different types of workloads. And so you can actually really tweak your volumes exactly to meet the requirements that you have. And the same goes for the different types of object storage as well. Important in all of this is that you can pick exactly that tool that you need. The same goes for example, instance types. In the past, maybe you would have been stuck with this particular type of server and you had to develop your software for it. These days, however, you develop your software and then you go look for what is the best instance type that actually matches what I need to do in my applications. And it also goes for storage, of course. I think still, sort of the ninth world wonder in terms of digital sense is Amazon S3. Yeah, it's the first service that we launched in AWS. It's now 13 years old. And customers are routinely processing exabytes of data when it comes to S3. And so whether it's all the mechanisms that we developed where you can automatically move between different storage classes, all the security capabilities that we put in there, all the object level controls that you have, it's been an amazing feat to see how S3 has evolved over time. And even to the point that you can use Redshift Spectrum to basically your data warehouse to point to your exabyte data set that lives in S3 and just run standard data warehouse queries over it. It's pretty spectacular. Now, one of the storage classes, of course, in S3 has been S3 Glacier, which is there to do long-term archiving. And we announced Glacier Deep Archive at reInvent. And I'm very happy to announce that that one is now generally available for everyone to use. The important part of Glacier Deep Archive is that it comes at a cost point of not even 1/10 of a cent per gigabyte per month. Yeah, no more Glacier, no more tapes, and it gets the same level of durability that you see in S3. And so this has a whole set of use cases that is pretty spectacular. One of them that I like because of my own history in healthcare is the fact that in the past when you had MRI and CAT scan images, they would be archived on film. The hospitals have a requirement that these data should be kept around for at least 30 years. So instead of keeping the digital formats, they basically printed it on film and then had radiologists later compare film instead of the digital images, mostly because they couldn't afford it. And there were no storage systems available that would actually sort of have this level of durability over such a long period of time. And so at these particular cost points, hospitals and others can now start storing huge amounts of data at a very low cost, but be guaranteed that the durability will be there for decades to come. So with all of these capabilities, we definitely see a move to newer types of applications. So if I look at what most of our customers are doing, it's sort of interesting to see that Amazon.com, the retailer, actually went through this phase 5 to 10 years ahead of that. We needed to reach scale and reliability, performance and security that most of our customers now are starting to get confronted with. So if you look at how development transformed at Amazon.com, it really went from what we know as sort of a monolithic application over to what's now a whole deep microservices environment. And so we'll talk a bit more about microservices in a minute, but it was in a digital business like Amazon, experimentation and fast experimentation is crucial. Continuously experimenting. And monoliths are not good for that. You have a very hard time to have this one big piece of software where many different teams have to work on together to be the really fast-moving innovator and experimenter. Doesn't really work. And so next to the scaling issues and all the technology issues that we had with running a monolith, we really wanted to break up all of that into a manner such that we could move fast. And the joking term that we used was that of 2 pizza teams. So teams that a service has a team associated with it that is really responsible for that service and completely, with full and total ownership, also over their roadmap. So these teams live by what I used to call, you build it, you run it. That's sort of the first days of what we now know as DevOps. So it was important for us because now that we've built this sort of decentralized environment, not only from an architectural point of view, but also from an organizational point of view, we could move really fast. We could start making new versions of some of these microservices and experiment with them in a much easier way than we ever could have done with a monolith. And a good example there is actually coming back to S3. When we launched S3 13 years ago, we had 8 separate microservices that made up S3. Some that did put, and others did get, and some of them did scanning storage and maintaining the index. So only 8 of those. But what we knew on day one when we were building S3 is that that would not be the architecture that we would be running 2, 3, 4, or 5 years later. Mostly with every order of magnitude growth, you have to sort of revisit your architecture. Now, if this would have been a massive monolith, this would have been a nightmare. Then at one moment you would get an email from Amazon saying like, oh, we're taking S3 offline on Friday night from 10 to midnight to build a new version. That would not be a good plan, would it? And so, as such, you need to be able to evolve your software while your customers are still running. And so now, S3 is well over 235 different distributed microservices, with all sorts of new capabilities that we've been building in over time, and also lessons that we learned. We learned that hardware, no matter how high-end it is, fails at times, and do really weird things like uncorrected bit flips in RAM that suddenly happen. And even though, you build them microservices that take that one particular job really well. And the thing with microservices is that many of these decomposed building blocks that you have out of your monolith, actually many of them have very different scaling and reliability requirements. And we'll get back to that. So if I look at sort of when Amazon as well as our customers go through this move from monolith to microservices, what's the impact on the way that we develop our software and that we operate it? And so let me go through some of these different phases in there. So first of all, when we look at these architectural patterns, the move from monolith to microservices is probably one of the biggest architectural changes that I'm seeing in the past years. The most important thing, and so let me tell you a story there about Amazon the retailer. So when we broke up the first monolith, we had 3 very large data sets. So customers, items, that's a catalog, and orders. And basically what we'd taken sort of business logic, moved it away, put it next to the databases, and we had these 3 very large services left. And one of them was the customer master service, basically all code that operated on the customer master database. Now, we learned over time pretty quickly that that was a mistake. We'd done a data-driven decomposition of our system, and we should have done a functional decomposition. Because in that customer master service, you would have one component that would basically be the recognized customer service, a login service, let's call it like that. And in that same piece of software, we'd also sit the address book service. That one's only needed when you do a checkout. Yet that login service is almost hit on every page. So now the whole component needs to scale at the scale of that smallest component that sits there. Plus, that this whole software component, this whole blob, has access to both the credential store as well as the address book store, which is almost a violation of security properties. And so really being able to decompose into the smallest building blocks that you can imagine, and then have each of those scale along the dimensions that they need to scale. And so the login service just by itself can scale tremendously without impacting the address book service. Now, 10 years ago, or was it 20 years ago, when we started going through this process and learning about it, I wish we had containers. We didn't. And so if you look at sort of the different types of compute available for you to support all of this, instances, VMs, virtual machines, containers, and Lambda all play an important role. And there's a clear shift happening over time away from instances into sort of more serverless development. But instances will be around for a very long time. So at this moment, we have 180 instance types for you, and whether that is sort of whether it's burst capability or general purpose or memory intensive or disk intensive or huge memory blobs if you want to run your SAP HANA systems. All of those capabilities need to be available because of so many different workloads that are available. And so where you can pick at one moment whatever instance type you really need to support the application that you're running. Now what you've asked us for is whether we can also reduce cost further. And so happy to announce today that the AMD-based instances are generally available, both in terms of both in the M and the R categories, so that is just general purpose as well as memory-intensive workloads. And so they're all based on the AMD EPYC 7000 processor. And basically, they have exactly the same numbering, the same family evolution as that the general purpose M's and R have, the Intel-based ones. So you can immediately start switching between one and the other. The advantage of the AMD ones is that they're about 10% lower cost than the previous instances we had. Now, if we look at containers, that clearly is the point where I see most of our customers that are moving to a microservices environment are actually making use of at this moment. Yeah, and there's a real rapid evolution in and around the containers happening because it makes it so easy to actually build this microservices environment on top of this. And we have really lots of customers that are actually really experimenting or building real production systems using containers. So think about McDonald's. Yeah? It's by any chance the world's largest restaurant chain with 37,000 locations around the world, serving 64 million people a day. So they built a home delivery system. They did this in 4 months using ECS, the Amazon ECS, the Elastic Container Service. And they serve 20,000 orders a second out of that microservices environment using containers. Typically, latencies are around 100 milliseconds, so this is an amazingly scalable environment that really has all the components, all the way built all the components to reach this massive scale. Also, put a whole API system around them, such that they can actually integrate with partners such as Uber Eats and others. A pretty impressive development of back-end services. Now, if we look at the capabilities available on AWS, there's different places where you need to make decisions. Yeah? So are you going to use the Elastic Container Service, or are you going to use the Elastic Container Service for Kubernetes, so ECS or EKS? Those are the two choices you have at the orchestration level. At the compute level, underneath your containers, you have a choice whether you want to manage those clusters yourself, or whether you want to make use of Fargate, which turns your container service into a serverless container service where you only have to worry about sort of building the software that has to run in your containers and not worry about the infrastructure anymore. And of course, with all of that, you need to have a container registry service that needs to be highly scalable. Now, we have some customers that pull the same image 4,000 times into different tasks. And so security and scale and reliability of the container service is crucial in all of this. Now, how to make choices between the different container services is more or less, is a choice you make often between highly opinionated systems or ones that actually give you way more flexibility. So whether you value simplicity over flexibility. And so if you look at ECS, that's clearly where I think simplicity rules. It's a highly opinionated service about how to build container-based applications. There's very deep integration with each and every one of the other AWS services, and whether it is ALB or CloudWatch or GuardDuty, all the integrations there are crucial. Yeah? And so, especially when it comes to auto-scaling and scaling over multiple availability zones, this is crucial. And so, many of our customers are making use of ECS because of this deep integration into AWS. And most of these are customers that really start building their first container systems on AWS itself. EKS, however, is much more flexibility oriented. Although we're deeply engaged with the open source community around Kubernetes, and we're 100% upstream. That means that we push all of our changes, all of the integrations that we do in AWS into the general repositories first and get them accepted there before we start launching this in EKS itself. Again, we're working on getting deeper integration into the AWS platform, but it also allows you often to already start developing this on your laptop or maybe on-premise and then start moving your container service over to AWS. And you see Kubernetes mostly happening by many of our customers who are looking to migrate into the cloud, where they really start building things in their own environment with the idea that they will be able to move this over to the cloud whenever they get to that particular point. In all of that, I've always been, definitely in the earlier days of container-based systems, I was kind of surprised about the willingness of everyone to manage, again, resources at the lowest level. Because if you think about containers, you really think about the applications you want to build. You don't want to manage servers or instances, clusters underneath there. And so we built AWS Fargate to take away all of the heavy lifting that comes with running container systems. Because really, you don't really need to manage those clusters. There's no value in that if you really want to focus just purely on building business logic. So whether the business logic runs in a container or whether you actually make use of truly serverless environment like Lambda, that's available for each and every one of you. So if you think about sort of the continuing from instances to containers and to Lambda, it is clear that there is a massive drive happening there. And many of our customers, especially those that are cloud first and thinking about building new applications, all start off with serverless today. And why? Because the productivity is just much higher. And you don't have to think about all these other pieces that you have to do around sort of provisioning infrastructure, running things over multiple AZs, managing your security posture, things like that. Many of these are all taken care of by Lambda itself. And of course, we continue to innovate there, looking at how you are building these serverless applications. And it's very interesting because this is a continuing. We continue to work with you because this is such a new world, serverless, that we need to make sure we're building the right tools for you. And so layers has become one of the important components on one hand to make sure that you don't have to upload redundant pieces of code. You can share these pieces of code between your different applications and version them and things like that. But also there's an ability for you to actually get one of your own application runtimes, your language runtimes, and integrate them there as a Lambda layer so you can run any programming language that you want to run. Now, and we see customers building pretty extensive things. If you look at this is Home Away. It's a company by Expedia. And so what they have, about 6 million images are being uploaded there. This is a vacation home brokerage service. People upload about 6 million images each month. And all these images need to be transformed into standard-sized images and into thumbnails, and also they need to be pushed through machine learning to see whether these images are appropriate and all these kind of things. And as you can see in the whole architecture, no servers. Everything is a combination between Lambda and other serverless components like DynamoDB and S3 and Kinesis. This is a pretty common architecture today, where there are no servers in this picture anymore. And we literally have hundreds of thousands of our customers that are all using Lambda. And the most amazing thing happened in all of this. When you think about sort of building new technologies, it's often the young technology startups that are sort of adopting this technology first. But what we've seen with Lambda is that actually enterprises jumping on board immediately. And why? Because it makes it so easy to only have to pay for those resources that you've really used. Very effective mechanism. But also, it creates so much greater productivity with your developers. That's really something that, as an enterprise, if you want to move fast, are really concerned about. And whether that is, for example, a company like Capital One, they migrated billions of mainframe transactions into a system with DynamoDB, Lambda, and other AWS services. Basically, completely eliminating the mainframe and instead going over to another container or another image-based system. No, they moved over completely. They jumped all over those steps and actually started using AWS Lambda to replace their mainframe with. Now, with all of these different components coming together, You know, you might have different languages, you might have different types of applications, and all of them are sort of running in this distributed environment. Then suddenly a whole other challenge comes up. How do these different microservices find each other? How do you discover? What do you do when you, how do you communicate with each other? How do you get visibility in which service is talking to which service with what particular load that they're actually pushing there? And also, what do you do when failures happen? How can you route traffic away? How can you, if things are starting to burn out from a performance point of view, how can you throttle your clients? All these kind of steps that you need to take if you suddenly live in this complete distributed environment. So for that, we built AWS AppMesh that makes use of the Envoy sidecar capabilities that actually now give you a complete view of the network, where you can have one consistent mechanism between the communication for all of the different components that now live in your distributed system. And actually indeed takes care of the reliability of the communication, of failure isolation, and actually gives you also insight into how communication is happening and what particular loads and what particular paths are being created. And also how to configure these. So all these capabilities in AppMesh, I'm happy to tell you today, they are also generally available for everyone to use. Yeah, and so this whole move to microservices is very important. And we see this happening not only in young businesses, but definitely also in more established enterprises. So Ellie Mae is a financial services company, a technology company that is moving all in onto AWS. And they're really embracing serverless. To hear more about their move to the cloud, let's welcome Satish Ravala, the SVP's Cloud Engineering of Ellie Mae on stage.
Thank you, Werner. Good morning, everyone. I'm really excited to be here to share Ellie Mae's journey to the cloud. Who is Ellie Mae? Sorry, slides were a little delayed. So Ellie Mae is a technology that powers American dream. Ellie Mae's mission is to automate everything that is automatable in the mortgage industry, to make home buying process easier for lenders and home buyers. Because at the end of the day, home buyers don't dream about a mortgage, they dream about a home. Today, 40% of all US mortgages are processed using Ellie Mae's technology. In today's reality, it's not easy or efficient for lenders or home buyers. So it's complicated and disjointed process with dizzying number of steps. So there is a better way. Ellie Mae has built a platform that helps solve this problem for our lenders to originate loans more efficiently and make better decisions based on the data. Let's take a closer look. A robust developer community. Ellie Mae's lending platform is a two-sided platform with lenders on one side and consumers and borrowers on the other side. Consumers and lenders and partners use this platform to process mortgages every day. We have a community of 5,000 developers innovating on our platform every single day. Our journey has begun in 1990s with a client-server architecture built for on-premise. Then we transitioned to SaaS in 2009. Then we transformed ourselves into a platform company in 2016, and that's built on AWS. Ellie Mae is moving all in to AWS, Our goal is to move 100% by end of 2020. There are many benefits of moving to the cloud. Given the seasonal nature of our business, you probably know most home buyers buy homes during springtime or summertime. So elasticity is key for our business. In addition to that, developer productivity and speed of innovation is key as well. Let me give you an example of one of the new products that we launched. We built an end-to-end data pipeline and data products that takes every data transaction and stores it in a data lake built on AWS. Provides analytics and insights on loan activity for our customers. We built this product from idea to go live within 6 months. This could have taken 2x longer if we had to build this on-premise environment. Let's take a look at some of the AWS services Elime is using. So like most of you, we leverage a wide variety of services. I think Werner touched on a few. We love Lambda. It not only saves money, it increases developer productivity significantly. Matter of fact, we processed 1 billion transactions in the month of January, last month alone, out of the trillion transactions that he was talking about. Speaking of saving money, we did some cost analysis. In phase 1, we are projecting 20% of cost savings when we move all in onto AWS. And more, in order to ensure, as we continue our transformation, we are anticipating much more deeper savings as we transform. In order to ensure success, the key for us is to enable a cloud culture within the organization. Moving to cloud in a regulated industry like us, there are a few things we needed to consider. We needed to ensure that our compliance and security requirements were met, while ensuring all the internal stakeholders are aligned. To help kickstart, accelerate our transformation, we engaged in a number of cloud-centric activities. I'd like to share some of them with you. Some of the key programs we have implemented included boot camps, Cloud Game Day, hackathons, and Technology Summit. AWS is a key partner with Game Day and meetups. As you all know, great people build great products. Happy developers build amazing products. I'm proud to say that's what our team does at Elime every day. Thank you.
Thank you. So with all of these new patterns that we see arriving, it's not just the architectural patterns, of course, that you have to keep in mind. You also have to think about, so what's the operational model? How I'm going to operate my services. And that dovetails a little bit with sort of whether you choose containers or instances or Lambda to build your applications into. Because there is a clear increasing complexity when you move to such a pervasive microservices environment. If you look at, just already talked about S3 moving into, was it well over 235 different microservices. But if you look at some of our customers, they're easily running thousands of different microservices as part of their overall system. And so, was it easier in the days when you ran everything in a monolith? Yeah, for some parts, definitely. Things were just a function call or a procedure call. Now you have to use AppMesh to sort of stitch all these pieces together and manage the reliability and the fault isolation there. But there's all these different choices you have to make. So what's the best operational model around it, such that you sort of minimize the churn that you have in terms of how to stitch these different services together. And whether you pick server full, and I consider instances as well as container services that are running not over Fargate. I consider them to be server full, because you still have to manage the underlying infrastructure for that. And containers over Fargate, as well as using Lambda, in terms of the compute side of it, is I think, sort of the first choice today. And we see most of our customers actually really embracing serverless as a cloud-first strategy. Except for maybe sometimes you have pre-built software that you came from a vendor and you still may need to run that in an instance. But I see most of our customers starting to build things around it using Lambda and serverless capabilities. But it's so much more serverless, by the way, than just Lambda. Lambda was just the last piece that was needed to stitch things together such that you never had to think about servers anymore. Now, I think the general model for serverless is really that you have no infrastructure to provision, it scales automatically, you only pay for what you've used, and the service itself manages high availability and security for you. And that's not just Lambda. I mean, it's all the different capabilities that we've seen at AWS over the years. S3 is serverless, matches this description perfectly. DynamoDB, or Aurora serverless, or all the other integration capabilities that we have to stitch your applications together, whether they're the step functions or SNS and SQS and API gateway and AppSync. And then as computational models, Lambda and Fargate. Serverless is a whole stack. It's not just compute. Just focusing on functions as a service is not serverless. It's the whole stack. On none of these pieces, you have to worry about the provisioning. You don't have to worry about sort of multi-AZ deployments. It is all taken care of for you under the covers. And that's truly what serverless is. And it really helps many of our large customers moving significant pieces of their infrastructure over into a serverless environment. Financial engines saved 95% in deployment and operational costs. Coca-Cola cuts down processing time from 36 hours to 10 seconds. And FINRA, the government organization that monitors the stock exchanges for fraudulent and anomalies and anomalous operations, literally validates about 500 billion stock market transactions a day using a serverless environment. And so it is really the first, let's say, the cloud-first strategy to look at serverless if you can build it there, because then you no longer have to worry about your infrastructure that you need to manage. So, and I've said this before, serverless really pushes it out to the limits where in the future you really will only write business logic. Nobody will be managing infrastructure anymore. What you operate is a higher level construct of microservices. Now, with all of that, of course, the way that we build software and deliver software needs to change as well. And if you often look at sort of the questions that we get asked when we think about microservices, the development is, so how does the release process work? How do you push code out? How do you debug it? How do you, because all of this is such a new environment that all the tools we have actually need to adapt to that as well. And so in the old life cycle, things were clear. You had one pipeline that actually delivered into production maybe every 3 months, or maybe every 6 months. Depends a bit on what kind of development strategy you're using, but most companies that were actually running a monolith really running sort of a waterfall models as well. Now, of course, the great thing with all these microservices is that the development lifecycle is very differently. Each of these teams are fully independent. Yeah, that means that they're able to really, every team can deliver at their own pace and immediately react to requests from customers. Yeah, in the old days, it was much harder if you have a monolith to actually be really agile and fast-moving and immediately react to your customers, because basically all your teams are working on the same piece of software, and that has a very heavyweight development process. Yeah, so best practices around all of this is still really try and not only decompose your architecture into smaller building blocks, but your organization as well, so that they can actually move fast, that each of these teams have total ownership over the software that they have and can actually really move fast based on the feedback that they're getting from their customers. And all of that, infrastructure as code and automation and all these kind of things play a crucial role. Now, these are all best practices that we've seen arrive over time. And many of us all have our favorite the development tools, and many of our partners are delivering great technologies there. And of course, in AWS, we needed to make sure that we have AWS cloud-native tools as well. Yeah, and so the whole code pipeline with code commit and deploy and sort of all the different testing tools that are available around it, and also integration with X-Ray and CloudWatch, we need to make sure that we have at least a whole set of very mature development tools for you so that you can automate these pipelines. And especially now with the rise of serverless and the rise of Lambda, we need to make sure that all of our development tools are really supporting these containers and Lambda as well. And so, most important, of course, if you build your systems, you need to be able to debug them. Or at minimum, you need to get a good idea into them. And so AWS X-Ray allows you to get a visualization of all the different components of your microservices environment, and whether those are running in containers or whether they're running in Lambda, and whether or not you use AppMesh there, it's integrated in all of that. And as such, you can get a visualization of any challenges or any problems that are happening in your completely distributed environment. And definitely when we think about sort of resource provisioning, you may have a case where you set certain read and write capabilities on your DynamoDB instance on one hand, and 5 microservices down the path is actually affected by how you have provisioned that. Now, in a distributed environment, that's pretty hard to figure out exactly where these challenges are. X-Ray gives you detailed insight and view of how your distributed systems application works. Now, with all of that, debugging is important. It's a very important part of our development process. So with the rise of serverless, we need to make sure that you can use your most popular tools to actually really build serverless applications on AWS. Yeah, and we had already announced Cloud9, of course, which is the AWS IDE environment. It is truly cloud native, but also PyCharm. And actually today, the IntelliJ toolkit is generally available, so you can build your Java and Python ones. VS Code is still in developer preview, but we expect that to go general available as well soon. And so for all of these, and I know we're pretty opinionated about what are the best development tools we have to use. Yeah? We just need to make sure that all of them work really well on AWS, and that you can develop in the way that that really is your style of development, and that goes through programming languages all the way over to what kind of IDE you want to use. Although I don't see any integration in VI and Emacs happening anytime soon. Yeah? But we do look at all the different kind of models. Yeah? So, for example, SAM is a different way of actually describing your serverless application in a way more declarative format instead of imperative. And so check out SAM if you really want to do local development as well, and it really helps you sort of think differently about how to compose your serverless application. Now, in all of that, I think there's one really crucial point that we all need to start thinking about as technologists. Yeah, and it is that in this whole continuous integration in development world, the deployment world, security suddenly becomes very different. And I think that we as technologists really need to take responsibility for making sure that we keep our customers and our businesses secure, even if we're changing operational and architectural models as fast as that we're doing. Now, if I look at sort of the past, and probably sort of the monolith idea, you would build software, the security team would come in, they sprinkle some magic dust over it, and suddenly your application is secure. Now, I think that may have worked maybe in the past, but I think today that's definitely no longer the case. I think most of these old-style security approaches all rely on the fact of building firewalls around it. Yeah? Now, if firewalls were the right security solution, we would still have moats around our cities. We don't. We protect our individual houses. We protect our individual rooms within our houses. So we should do that in our digital systems as well. And remember, if you look at most of the threat data or the security data, it shows that these brute force front door attacks almost never happen anymore. It's all about social engineering. Someone in your organization will get an email that says, oh, this is your new retirement package. Click this link to sign it. There is always an idiot that clicks that link. Because if not, they wouldn't be doing it, would it? Yeah, and so there's always some evil JavaScript gets downloaded, tunnel gets established, and if they're not, the individual pieces in your organizations are individually protected, everything is toast. And I think what we've seen in the past years, with the number of data breaches that have happened, most of those, or almost all of them, are related to sort of old digital systems that have been brought online, or old operational practices that were appropriate maybe 5 or 10 years ago when you were building it according to a waterfall model and things like that. Those are no longer applicable now. Yeah, the security team looks very different today than 10, 15 years ago. Yeah, we have all these different components that we have to take care of. And it's no longer a separate security team. It is us as builders that are responsible for this. Security needs to become everyone's job. Now, with all these data breaches that we've seen in the past years, we need to make sure that we protect our customers and our business. And it's our responsibility as technologists. Yeah, we really need to make sure that now that we are moving to more and more digital systems, and most of these digital systems are developed in a very different, much faster moving way, that we do not forget that security needs to change with this. Yeah, and it's both the security of the pipeline itself, as well as the sort of software that you develop inside your pipeline. Yeah, and make sure that your pipeline has hardened development services that you have total control over. Yeah, and then make sure that all the components that you're building actually, in each step of this, that you check against, are we introducing new vulnerabilities or not? What kind of alarms should go off? If you do 100 deployments a day, yeah, security needs to look different. And so if this is sort of a traditional setup for your continuous integration and deployment, we need to make sure that in each of these steps that are happening, security is becoming paramount. Yeah? And so whether you do the continuous scans, whether if there's changes happening in your configuration, alarm bells need to go off. And sometimes either automated or sometimes manual checks need to happen. If someone adds a new library to your application, an alarm needs to go off. Because someone needs to see whether this is actually a library that has been approved, that maybe it's an open source library, what are the vulnerabilities that come with it, all these kind of steps. And why is this library being added? And all of these kind of things, you need to make sure that you can automate that as much as possible. And if you look at sort of the different components there, definitely infrastructure as code plays a crucial role in all of that, because that means that you can actually see the changes that are happening in your infrastructure configuration between one and the other. And so if you look at when in this whole development process, you need to actually have all sorts of operations happening. It is both when you push new code that actually needs to go through, it needs to go through code scanners, it needs to look at sort of new libraries and new dependencies being introduced, or whenever these event triggers happen. And event triggers can be whenever a change happens, or whenever you need to do that on a daily basis, or whenever you change frameworks. And then afterwards, you need to continue to validate whether actually the application is still meeting your security and maybe compliance requirements. In all of that, automation plays a crucial role. And of course, in the world that we live in, there's this shared responsibility model. AWS takes care of a large part of the operational environment for you, and we built also all these new tools for you to use. There's a whole collection of AWS automation tools around security that you all should be using. Because I think that really, if you really want to move to a world that is secure, you need to automate as much of the security processes as possible. Now, let me just pick a few of these that I really like. So, Amazon Inspector basically continuously inspects your code that you're running, whether you have introduced new vulnerabilities. And on one hand, that might be just scanning against well-known vulnerabilities, but it might also be the case that you are subject to particular compliance regulations. An inspector can actually check whether you are still in compliance. And this is important. Remember that maybe you need to process credit card transactions. You need to be PCI compliant. And if you now make 100 changes to your code a day, are you still in compliance? In compliance with the regulations? An inspector can help you with that by really diving deep on sort of the changes that you've made in a completely automated fashion. So make use of it. CloudTrail, if you've not enabled CloudTrail, then you're really missing out on getting detailed information about how your systems are being used. CloudTrail really logs every possible operation on every object, on every resource that is happening. And you can continuously record all these API calls and then stores them into S3, over which you can have CloudWatch and other analytics tools then run over and take a look at sort of really, are there anomalies happening? In all of this, when you think about security, as I said before, encryption is what it's all about. So dance like no one's watching and encrypt like everyone is. Important in all of this is that encryption is the tool we have to make sure that nobody else has access to our data. So, for example, with Amazon, the retailer, we indeed need to be PCI compliant. That means that about 15% of your calls and storage operations need to be encrypted. We just decided to encrypt everything. That means that none of your engineers can no longer make a mistake about should they encrypt this, should they not encrypt it, and your PCI audits becoming really simple in that manner. So, given that we've built encryption into almost all of the AWS services, make use of it. 5, 10 years ago, we may have had this discussion whether HTTPS was too expensive. Now every consumer service runs over HTTPS. The same goes for encryption. For a long time we've said, oh no, these tools are way too hard to use and it costs too much. And it turns out we're now building these tools that don't make it that difficult for you. And whether you have integration of encryption into all the different services, or whether you can just bring your own key with KMS. And remember, this means that you have total control over who has access to your data. Look at Redshift. Redshift encrypts every data block with a random key, always. And then that set of random keys is encrypted with a master key. Now, you can bring your own master key, or we can generate it for you. But most importantly, if you generate your master key, you're the only one who can decide who has access to your data. So encryption is the most important tool you have to protect your customers. With all of this, I think as technologists, we need to take responsibility here. We need to make sure that the next generation of systems that we're building have security as a first-grade citizen. Where you need to start thinking about protecting your customers on day one. And I know if you're a young business and you start to innovate, you start thinking about all these new things that you want to build, security might not be on the forefront of your mind, but it should be. And definitely us as technologists need to take responsibility for that, making sure that the next generation of systems are as secure as they can be using the automated tools that we give you. Now, in all of this, there's also changes to data and data management that are happening, of course, and that we at AWS needed to make sure that you have the right tools to use. And so many of our customers were running databases themselves, enterprise-grade databases on-premise, and many of you have asked us to help you move to open source. And whether that is MySQL or Postgres or MariaDB, mostly not because of the capabilities necessarily of these database engines, but because the licensing terms that the old guard is using is truly restrictive. It's almost comes back to blackmail. Yeah? The only way for you to drive your costs down is to make very long-term commitments, and then buy many more licenses than you ever need. Now, I've been on the receiving end of that. If I had to buy more databases, the only way to drive costs down was to make a 5 or 10-year commitment. I don't know how many databases Amazon will need in 10 years from now, but that was something you need to decide at that moment. So many of our customers really want to move away from that sort of restrictive environment and really want to move over to the cloud, preferable using standard interfaces like MySQL or Postgres, but really, really would like an enterprise-grade database in the backend. Now, none of these relational databases actually have been designed for the cloud. Now, the only way that we can really scale them out, instead of scaling up, is to actually make use of sharding. Yeah, and whether you do that at the application level, or do you do it at the SQL level, or whether you do it in some weird storage mechanism, those are the ways that you can make use of these databases to scale them out. But remember, this is technology developed in the 90s. It's not modern development. It all requires a local disk. Or even if you cluster of databases, they still require a shared disk. And each of those instances have a whole stack in them that actually is very much duplicating everything. So with all of that, we built Amazon Aurora, where we basically ripped the whole database engine apart. So Aurora has 2 interfaces, has a MySQL interface and a Postgres interface. But behind the covers, we've ripped everything apart more or less at the middle of the caching layer. I moved to a shared storage service based on SSDs, which is actually database aware. And this is has allowed us to build a much faster, much higher reliability system than we could ever build using the standard off-the-shelf databases. We actually make use of 6x replication. So if you build these distributed storage engines, you use quorum technology to make sure that you can actually read the last write. And so typical scenario is there where the quorum is 3 nodes, and you need to have at least 2 nodes available to write, and you need to have 2 nodes available to read, such as there's an overlap, and you can always read the last write. Now, in our scenario, we believe that there are failure scenarios out there that are much more dangerous to the reliability of such a database. In our case, we would really like to survive at least the failure of 1 complete AZ. And while there's a complete AZ that may have failed, in that particular time frame, there's a likelihood that one of your other nodes may fail as well. It's just, when it rains, it pours. And so we really want to make sure that we have an AZ plus 1 failure scenario, where we can lose a whole AZ and 1 node. In this particular case, you need to go down to a quorum system of 6. So we do 6-way replication to make sure that we have a continuous overlap in these scenarios. So that means that if you lose an AZ and you lose a node, you may no longer be able to write, but you can still read. And then we need to make sure that the repair for writes is really fast. And we do that by making sure that the individual blocks that are being stored in the storage service are really small. So it's 10 gigs, meaning that you can very quickly repair a failed write by actually re-replicating the data underneath there. Now, in all of this, that's the reliability side of things. It is also very important to make major improvements to the way the performance in these traditional databases is restricted, because their whole thinking is about a local disk. Now, if you look at a typical MySQL write, is actually any write to the database will result in 5 writes to the storage engine, which then writes 5 times to the backup engine. Then you write all that data to your replica, who then also does all of these storage operations. Yeah? This is hugely expensive. And so you move the data pages, you do double writes to avoid corruption happening, you move the logs, you move metadata. All of these different pieces are being written. Now, it turns out that that's hugely wasteful. It turns out that it's only the log that you actually need to write. Because in the log, you'll find the before and the after picture of your data page. And so you don't need to move the data page. Yeah, you can just move in the log. And so in Aurora, we only move the log, write the log, to the storage engines. And then the storage engines are not just storage engines, they're database aware. Because you can actually recreate a data page by just purely looking at the log. And the only reason why you would ever need to move a data page from your storage engine into the database is if there's a cache miss. Well, it's most likely that the most recent transaction that you actually completed will still be hot in your own cache. So you can actually recreate these data pages in a very lazy fashion. What you see here is that the primary instance writes the log, gets persistent. At that moment, you can already acknowledgement the write. Right? Then gossips with the other storage nodes, the other 6 storage nodes, to actually transport data there. And then in a lazy manner, you can start recreating your data pages. All of this has allowed us to create a foundation for true innovation in databases. That was never before. No other database systems can do this kind of innovation because they're still stuck in the old architecture. Decompose it into smaller building blocks and then apply standard distributed systems techniques to them to actually keep them reliable and performant. And so all this gives us a basis for database innovation that is pretty spectacular. If you ever programmed in a language that has object relational mapping available, like Ruby on Rails, for example, any changes to your data structure will immediately result in a change in your schema. For that, old-style databases need to do a complete table copy. However, in Aurora, basically creating a new database or creating a new table based on the old table is a matter of microseconds. Because we can create that new table in a lazy manner, because the storage is database log aware. So Aurora has been a great success, fastest growing service in the history of AWS. And it's still growing very fast, mostly also because we're able to push all these new innovations through there. And it's not just relational. We talked about this earlier. Definitely the move to microservices has made everybody aware that, oh, wait, maybe I can pick the right tool for the job. This particular microservice just needs a graph database. Yeah, or maybe you're operating in a world where you've been considering blockchain style of interactions, where you're looking for an immutable ledger, and you make use of QLDB. So each and every one of these services serve a really particular pattern. DynamoDB has its roots in a deep dive that we did at Amazon, the retailer itself. We did this in 2004. And when we did a deep dive on how we were using relational databases, it turned out that 70% of the usage of these relational databases was key value. There would only be a single key in the query, and you would get a single row back. 70%. Well, we knew that we could build very different types of databases that would be uniquely positioned to serve a key value world. Yeah, and we could have tight control over performance, reliability, all of those. And Dynamo became that. And DynamoDB later became the service version of that we had in AWS. But again, it turns out that DynamoDB is a powerhouse now for everyone that wants to do truly scalable operations. If you think about Supercell, For example, the company that makes games, they made these games, Clash of Clans and others, on day one of a game, they will literally have millions of players checking out the game. That means that your data storage behind it need to be extremely scalable, because a bad experience on day one will not have gamers come back. And so DynamoDB is the powerhouse that sits behind all of that. Now, everyone is looking to get more value out of their data. I mean, one of the things that cloud has done is made the whole IT landscape egalitarian. Everybody has access to the same storage, the same compute, the same databases, the same analytics tools, the same IoT tools, the same ingestion tools. Everyone has access to that now. So IT capabilities are no longer a competitive differentiator. So what is then the differentiator? It's the kind of data that you have and how smartly you make use of that data. And so we need to make sure that we can actually help you pick exactly the analytics tools you need to use to operate on your data. Yeah, and whether that is sort of in the analytics space, or how to create data lakes, or how to move data in and out of your data lake. Yeah, and so all of this is crucial for you to pick exactly the right tool. You want to do ad hoc queries? Use Athena. You want to make use of Hadoop? Use EMR. You want to just do very complex traditional data warehouse queries? You make use of Redshift. And so pick exactly that right tool for the job. Yeah, after all, Redshift is a data warehouse that you can just fire up on demand. Where in the past, maybe data warehouses were something that was very expensive and centralized. You all needed to queue up for that. What we now see is that many business units are just firing up a data warehouse for 2 hours on the Thursday afternoon. That is a radical shift in how databases and data warehouses are being used, including at Amazon. Yeah, and I've claimed before that of the past year, November 1 was one of my happiest days of the year, when we shut down one of the world's largest, if not the largest, Oracle data warehouse. And we replaced it. And we replaced it with Redshift at Amazon. Yeah, and so with all of this, we now truly move to an environment that moves so much faster, so much more agile. Because indeed, in the old-style data warehouses, it's such an expensive piece of software and hardware that everyone needs to load it up to the max, and you always need to wait for it. And especially if you want to run some ad hoc queries, try and forget that. You're back in the queue where maybe your queries get executed tomorrow. And it's really absolutely becoming the most popular cloud data warehouse out there because it's so easy to instantiate. And so Intuit moved all of their mission-critical analytics workloads over to Redshift instead of its on-premise environment. And moving so much faster. The cool thing with Redshift is that we've enabled deep metrics, application and database metrics into the system. And as such, we're able to really observe how our customers are using our software and then working with our customers, understanding how we can actually speed things up for them. And in the past 2 years, we've been able, with all these improvements to speed, to make Redshift 10 times faster. Mostly because really this close interaction with our customers, really trying to understand what are the kind of things we can do, short query acceleration, or resizing, elastic resizing, or how to speed up interactive queries. All of these kind of things is working together with our customers, understanding what are the patterns you use in a modern data warehouse. And that has led to enormous speed improvements over time based on the feedback of our customers. Now, one of the other things I just talked about is sort of waiting for your queries. Now, it turns out that 87% of our customers never wait for their queries. But what's the other 13%? What are the kind of things that we can do in terms of innovation in our data warehouse to make sure that you never have to wait? So with that, we've launched Redshift concurrency scaling, which is, by the way, today generally available. Yeah. So what does concurrency scaling do? So we basically make burst clusters available for you. That if we see the queues of queries sort of rising to the point where you actually have to wait to execute the query, we can fire up additional additional clusters for you such that your customers never have to wait. And so much of this comes actually at no cost at all to our customers. Yeah? Because we will actually sort of fire up these queries for you in this cluster without actually charging you extra for that. Now, analytics plays a very crucial role. And we often think about analytics as, oh yeah, that's sort of the data warehousing, this the old style world. But if you look at sort of every modern young business or every modern young application that's being built has data generation and analytics integrated into it. Well, we all know about Fortnite. Yeah? Nobody here plays Fortnite? Yeah, liars. Yeah. By the way, I survived not more than 5 minutes, so I can claim I've done that. More importantly, next to sort of all the efforts that the Epic guys have put into building Fortnite as a game, they put enormous amount of effort into data generation around that. And whether it's the game clients or the servers or different types of pieces that all generate data for them, you have a massive analytics environment sitting underneath that, serving different pieces of the business. On one hand, real time, like service health and tournaments. Yeah, but on the other hand, also just business capabilities, like just measuring your KPIs, or actually analyzing how the game is being used such that the next generation of your game that you're building is actually meeting sort of the ways that your customers are playing it. And so I've always looked at sort of in these things as analytics having 3 different pillars. One of them is looking backwards. Yeah, and looking backwards really means sort of the redshift type of operations, EMR, where you're generating reports. And then there's the real-time part. There's a real-time pillar, where you use Kinesis and Elasticsearch and EMR to probably look at what is my inventory level right now. I'm not interested in my inventory level yesterday. I want to know what it is now. And that is real-time operations. And then there's the third one. The third one is how to predict the future. Right? So looking backwards, what's now, what's the future? Now, we're really bad, I think, at predicting the future. So the best next thing that we can do is make use of data that we already have and be smarter with it, using AI and machine learning. So with that, I'd like to invite Dr. Matt Wood on stage, the General Manager of Deep Learning in Artificial Intelligence, to talk to you more about that. Matt.
Good morning, everybody, and thank you, Werner. So, as I'm sure many of you are aware, we're entering a new golden age for machine learning, where many of the constraints which have held back the application of artificial intelligence and machine learning to real-world problems start to melt away in the cloud. And as a result of that, we're starting to see tens of thousands of companies in virtually every industry and in virtually every size and shape start to apply machine learning to their central core challenges. Whether it is change in healthcare through Change Healthcare, whether it is advancement in life sciences with folks like Bristol-Myers Squibb and Celgene, folks progressing manufacturing, allowing it to operate more efficiently, telephony, contact centers, you name it. Machine learning has arrived in virtually every industry, and it's incredibly exciting to be part of the team at AWS, which is helping customers drive this forward. And a big part of why we're seeing this stratospheric movement and advancement in machine learning is that on AWS, there are a number of really key tailwinds. These are forces and services and capabilities which are available to developers just like you, which drive significant acceleration in your use of machine learning. And what I'd like to do today is just run through the 4 key tailwinds that we're seeing in the trenches at AWS, and run through what I think are the key challenges and the key solutions which are only available to customers today on AWS. The first tailwind, which is driving developers to do more with their data, is a broad and deep set of capabilities which aim to put machine learning in the hands of every developer. We joke internally that we just want to make machine learning boring. We want it to be just another tool in the tool chest, which is available whenever and however you need it. And to do this, we make 3 main areas of investment. The first is an investment in the fundamental machine learning frameworks and infrastructure related to machine learning. So this is typically where the advanced machine learning applied scientists live as they're building out advanced models, researching new ones, or even iterating on the key frameworks themselves. And these frameworks are how you define your neural networks and your workflows to train your models, and then that's where you run the inference to make predictions against your models. They're almost all open source. They have some strange names, such as TensorFlow, MXNet, and PyTorch. There are other high-level interfaces, such as Gluon and Keras. And our approach here is maybe a little bit different from others. Our approach here is that we want to support all of these incredibly well and make sure that they run as well as possible up on AWS. And the reason for this is that as the science of machine learning is advancing, new techniques and models and approaches and architectures are being made available virtually every single week. And those architectures, they exist in all of these different frameworks. They're published with reference architectures in all of these different frameworks. And so just picking or trying to standardize on one is not the right approach because you lose access to all the other innovation which is happening in all the other frameworks. So our approach is to invest in all of these areas. And we actually have separable teams at AWS which focus on TensorFlow and MXNet and PyTorch and so on. And we'll keep doing that as more and more of these frameworks start to appear. So part of the approach is we want this to be as easy as possible for developers to use. And so we take all of these frameworks and we run them on world-class infrastructure that a lot of you are familiar with on EC2, and we make it available in different ways. We make it available in a fully managed service, which we call SageMaker, which I'll talk a little bit more about in a second. But we also make it available in an AMI, or an ARMI, where we take and optimize all of these frameworks and just make it a single click to deploy them up on EC2. And this DIY approach is really popular with scientists and applied machine learning developers who want to get in and tinker at a very, very low level and potentially even build more frameworks going forwards. But as Werner's been talking about, we see a definite trend with more and more developers turning to use containers. And so we want to apply the same approach where we're packaging, optimizing, configuring, installing all of these frameworks and make them available not just in an ARMI, but as a container. And so today, I'm very proud to announce AWS Deep Learning Containers. These deep learning containers allow you to quickly set up deep learning environments up on EC2 using Docker containers. They run on Kubernetes or ECS and EKS. We've done all the hard work of building, compiling, generating, configuring, optimizing all of these frameworks. So you don't have to. And that just means that you do less of the undifferentiated heavy lifting of installing these very, very complicated frameworks and then maintaining them because they all move very, very quickly. And we'll be releasing new containers as new major versions are made available for TensorFlow and MXNet, and we'll be adding PyTorch very, very soon. They're available in the AWS Marketplace and through the EC2 Container Registry. So moving up a tier, the second major area where we're making investments is the machine learning services. And our big investment here is a service called SageMaker. And what SageMaker attempts to do is it attempts to bring machine learning and put it in the hands of any developer, irrespective of the skill level that they have as it relates to machine learning. And it's sometimes easy to forget just how challenging machine learning used to be before with the introduction of SageMaker. Virtually every step of the machine learning workflow presented a hurdle or a wall for most developers who didn't have deep skills in machine learning or deep learning. And combined, these walls were effectively infinitely wide and infinitely high. They were just impossible for most developers to climb over or dig around. But with SageMaker, we systematically approached each of these key challenges and started to remove them behind a managed service, which is very, very easy to use. So for developers who need to collect and prepare training data, this is everybody, by the way, that wants to do machine learning pretty much, we replaced that with pre-built notebooks for common problems. And a managed notebook service, which with a single click gives you a notebook environment where you can start to experiment and slice and dice your data. Instead of having to choose and optimize your own machine learning algorithms, we built in a set of over a dozen high-performance algorithms. These are optimized for AWS, and we use some clever techniques to allow them to stream data from S3 and train in a single pass, which dramatically increases the accuracy you can obtain and reduces the cost of running them. We allow one-click training, so with a single click, we can spin up a fully managed distributed cluster under the hood for you to run your training against. And then we added optimization. So a dirty secret of successful machine learning is that you don't just train one model, you train 1,000 and just pick the best one. And this has traditionally been kind of a trial and error approach. But instead of that, in SageMaker, we have a service which provides hyperparameter optimization, and with a single click, will drive and actually guide the search for the best possible model using machine learning under the hood. When you've got a model that you love, you can make a single click and deploy it in a fully managed environment, and then scale that environment for production use using auto-scaling, so you can scale up and scale down. And the result of this is that more than 10,000 developers today are using Amazon SageMaker to drive their machine learning workloads. And many are standardizing on the platform as their machine learning central repository of data and analytics related to ML. The third main area, we want to provide these sorts of capabilities to application developers who don't necessarily have any machine learning experience. And so here we provide a set of AI services which mimic, in many cases, some level of human cognition. And so we have a set of services for vision, so computer vision, recognition to do image and video analysis, and textract to automatically extract data from scanned documents. We do a lot of work around speech, both the generation of speech using a service called Polly, that's the same service that we use to generate the voice of Alexa, and transcription, where we take speech and turn it into text. And then investments in language models, where without any machine learning expertise, you can start to apply natural language processing and translation to the text that you potentially captured through speech. We build conversational interfaces using Lex. That's the same natural language understanding system that we use under the hood with Alexa for building conversational interfaces. And just in December last year, we announced 2 new services for forecasting and for recommendations. And this allows you to build out very, very accurate deep learning-driven forecasts and deep learning-driven recommendations based on the same technology that we use on the retail side of the house at Amazon.com. Now, what's interesting about these last 2 services, Forecast and Personalize, is that unlike some of these other deep learning systems, unfortunately, there is no master algorithm for driving the very best forecast. There is no master algorithm for driving the very best personalization experience, whether it is predicting the news articles or ordering search results. And as a result, what you need to do is you want to be able to take the data that you already have and then train your own models which are specifically for your data and for your customers. That's by far the best way of approaching it. But the challenge is that this is incredibly complicated. And so what we do here is we apply a technique that some people call AutoML, where we take in a lot of input data, so a real-time activity stream of what's going on the platform in terms of personalize, the inventory, so the articles or the products that you have, along with any demographic information, optionally, that you want to provide to drive the personalization engine. And then with a single click, just 3 API calls, you can build a customized version just for you for personalization and recommendation, which we host behind an API on your behalf. Now, we don't use any of the data. It's customized for you. We don't share it in any way. This is just a specific private model for your use. But under the hood, we're doing a world of things to make this possible. And one of the great things that keeps me skipping into work every morning is the opportunity to invent and simplify relating to machine learning on behalf of our customers. I think this is an excellent example, where Personalize under the hood is using machine learning to make all of these decisions. And we've trained those machine learning models based on knowledge that we've had building several dozen personalization systems at Amazon.com. And then we drive the workflow from loading the data, inspecting the data, selecting the right algorithms, training the models, optimizing them, all of that, all the way through to hosting them, building the feature stores and the caches on your behalf so that you don't have to worry about it. So this is a step function change in the speed at which you can start to introduce deep learning and machine learning into your organizations. The second tailwind is that customers are able to take advantage of AWS to increase the performance of their machine learning applications whilst also lowering costs. Normally, you have to choose between the two, but we think that's a false choice. And so it's never been cheaper or easier to run your machine learning workloads on AWS. So machine learning, you take the data that you have, usually stored in S3, you run it through a training system, and then you use inference to make predictions. And usually do that, as I say, inside these frameworks. So I'll just use TensorFlow as an example. So TensorFlow, very popular, great tool. About 85% of all TensorFlow workloads out there today run on AWS. And we see this across virtually every industry, whether it is Intuit or Siemens or hot startups like Huddle. They're all using TensorFlow up on AWS. Now, the challenge with TensorFlow is, whilst it's a great tool, it's got a lot of opportunity for developer productivity, once you start to get to production and you train on very, very large amounts of data, you start to get a scaling hit. So it's not particularly efficient when it comes to scaling across dozens or even hundreds of GPUs. And so what we did with our TensorFlow team is we went super deep into the central engine of TensorFlow. And we optimized the networking to be less chatty and to be more efficient across the AWS network. And what we saw is that using our AWS optimized version of TensorFlow, which is available in the containers and in the Army as well as SageMaker, you can train at nearly twice the speed. So with stock TensorFlow, you're operating at about 65% efficiency across 256 GPUs. That means for every dollar that you spend, only 65 cents of that dollar is used for anything actual good. The rest is just overhead. Moving to the AWS optimized version, we see a 90% scaling efficiency. Now, you'll never get to 100%. It's just not possible today. But 90% is a significant increase in speed. And what that means is you can train your models with more data, you can train your models faster, and you make better use of your most expensive resource, which is your data scientists and your developers, which are using the machine learning techniques. But another dirty secret of machine learning that I'll let you guys into is that whilst training is incredibly important, there's a lot of focus there, it's actually only a fraction of the total cost of a machine learning workload. And running inference in production is the overwhelming majority of cost when you start to break it down. About 90% of the cost of a significant machine learning system is running predictions against your trained models. And so whilst we'll continue to optimize on training, we're going to continue to focus on optimizing this big chunk of work, which is improving inference costs. We're doing that today with a service called Elastic Inference. This allows you to, as a service, add a slice of GPU acceleration for your smaller models, and then dial up the GPU acceleration at the end of an API when you need to increase the throughput or you start to work with larger models. And just this service alone can decrease your inference costs, which is the majority, by up to 75%. You can scale that from a single trillion operation per second, which sounds like a lot, but actually isn't in terms of machine learning, all the way up to very, very big, beefy models, such as up to about 32 trillions of operations per second. And we've already built this into TensorFlow MXNet, and we'll support any model which conforms to the ONNX standard. Coming up towards the end of the year, we're going to see AWS Inferentia start to be introduced. And this is our AWS-designed custom machine learning inference chip. And this is designed for more sophisticated models which can take advantage of an entire chip with high throughput, low latency, and with a single chip operating at hundreds of TOPS, but can be combined together to operate at thousands of TOPS. And we're going to make these available through EC2 instances, through SageMaker, and also under the hood of Elastic Inference. So if you start using that service today, when we introduce Inferentia later this year, you'll start to see just an automatic increase. The third tailwind is that it's never been easier, faster, or cheaper to get data ready for machine learning. This is an area where a lot of organizations spend a remarkable amount of time. And honing and producing accurate training sets is one of the most important ways to build successful machine learning models. So these models require very, very large amounts of data, tens of millions of images. And so if you're building, say, an autonomous driving system, what you need to do is you need to take every photo, every frame of the cars that are driving around collecting this data, and you need to annotate it in some way. You need to tell the model through training what is important and what is not important. And the way that that's done today primarily is through humans. You show all of those images to humans, several at a time, and you get them to say, this is sidewalk, this is a car, this is a stop sign. And these annotations, these labels, are what allow the machine learning systems to learn. However, it's extremely costly and incredibly complex to do this at any sort of scale. Because not only are you managing the data, you're also managing the humans that have to go off and actually provide the annotations. And so we provide a service uniquely on AWS which is built into SageMaker, which we call Ground Truth. And Ground Truth allows you to build highly accurate training data sets, which reduce training data set preparation costs by up to 70%. And we do that under the hood by using a technique called active learning. We take data, and as it's being annotated by the humans, we capture all of that cognitive investment, and we train a machine learning model as we go. And it progressively gets better and better and better and more accurate. It learns more features as the training is taking place. And this means that as you train more data, you can offload with confidence more and more of the annotations to the system which you're training as you go. So with no additional overhead, you start to dramatically reduce as you go the number of images which need to be shown to humans. In addition to that, we have world-class workflows and tooling to allow humans to provide those annotations. But the key to driving down cost is to learn as you go, capturing that cognitive investment. The final area is that it's never been easier to learn about machine learning. One of the things I love about the AWS community is just an insatiable desire to broaden skills and expand their knowledge. And on AWS, it's never been easier to make this investment for yourselves in machine learning. We've taken the machine learning university content that we use to train our own engineers at Amazon, and we've made that available in a self-service way through our training portal. This is one of our most successful training programs to date. We also make our own engineers. These are folks that have built things like Personalize and Forecast, the engineering teams that are involved in the personalization platform over on the retail side of the store, and we'll make that team available to you to get hands-on keyboards to build initial POCs. So our goal here isn't to build a big professional services organization. We just want to help spread the knowledge as much as possible through a program we have called the Machine Learning Solutions Lab. And if you're more of a do-it-yourself person, as I am, then we make some products available to help you learn. One of them is called Deep Lens. It's the world's first deep learning-enabled video camera for developers. And this allows you to capture data, train against that data, build models in SageMaker, and with a click of a button, we'll deploy them directly onto the device. So these models are actually running on the camera. And then pretty much everybody has things on their desk for object recognition and people that they can use. And with this fast feedback loop, you can start to learn and experiment, which is a fantastic way of broadening your machine learning knowledge. At reInvent, our developer conference in Las Vegas last year, we also introduced AWS Deep Racer. This is a fully autonomous 1/18th scale race car, which is driven by a type of machine learning called reinforcement learning. You build your models in a simulator up on the cloud. You specify a scoring function, very easy to do without any machine learning knowledge required, and then you use that scoring function in a simulator to train a racing model, which you can deploy down onto a car and then race around a track. And when we started doing this at Amazon, we saw very quickly, and we should have seen this coming, our engineers started to race these devices. And so we're also announcing the AWS Deep Racer League. This is a global racing league that anyone can participate in. You can build your reinforcement learning models up in the cloud. We're starting a series of Deep Racer League races at the AWS summits across the world. I encourage you to attend them all. There's credit for doing more than one. And the winner from every single race, at every single summit, the person that has the fastest time around our test track, will win an all-expenses-paid trip to reInvent to participate in our championship cup in 2019. We're also running, if you can't get to a summit or you don't have a car, a series of virtual tournaments running every month through the year. So I'm very pleased to announce that this is starting today. You can head down to the expo. You can take some models. You can start racing them around the track. We have a real professional commentator from motor racing to narrate the tracks. It's a lot of fun. And we have a leaderboard that you can all look up on your phones and track how you're doing. So across all of these services, the capabilities made available on AWS are remarkable. They are more broad and more deep than anywhere else. And all of these tailwinds across price performance, across data preparation, and across these learning capabilities are only available on AWS, and they're specifically designed to help developers and builders like you get up and running with machine learning. And to tell us a little bit more about what they've done at Workday, I'm very proud to introduce Ellen, who is the head of data science and architecture. Thanks very much.
Thanks, Matt. Good morning, everyone. Would you believe that we spend close to 2,000 hours at work every year? Sometimes it feels like more than that. What I love about Workday is that we touch 37 million lives and make their 2,000 hours at work better and brighter. Workday is the leading provider of enterprise cloud applications. We deliver applications for financial management, human resource management, analytics, and planning. Workday delivers an incredible, trusted system of record for some of the largest companies in the world. We serve much of the Fortune 500. My background is in machine learning and is in building machine learning and data products. And I'm passionate about using machine learning to solve some of the hardest problems in enterprise software. On top of the system of record, the incredible trusted system of record we have a layer of engagement that delivers reporting, analytics, and planning. My team in Workday is focused on delivering a system of insight using machine learning that helps our customers do their best work. We have identified a few areas where machine learning makes a big difference for our customers. We all know how hard and important it is to hire and retain the best talent. We are on a mission to transform how you identify, hire, and retain your best talent. In the world of financials, having the right insight at the right time and the right context is everything. We are transforming the financial systems with streamlined workflows and powerful predictions. Today, we all expect personalized experiences in every aspect of our life. We are focused on delivering personalized recommendations that make you better informed, more productive, maybe even a little bit smarter. To do all these things, we needed a solid set of tools and the right partner to get us there and get us there fast. At Workday, privacy and security of our customers comes first. So naturally, first we needed a solid foundation that ensures the privacy and security of our customers, and a system that enabled us to track data lineage at a fine granularity so that we can implement privacy by design. Once this system was in place, the foundation was in place, we gave our data scientists the best machine learning and data tools. And of course, the fastest compute for them to train the machine learning models. We selected AWS as our partner in this journey and built our machine learning environment on AWS using a variety of services. This diagram illustrates our ML workflow and the services that we are using. Let me use an example to illustrate how this works. One of the financials product we have is mobile expenses. Imagine you are on a business travel, and you have a ton of receipts that you're collecting as you expense for a variety of stuff. Mobile expenses allow you to take a picture of your receipt and file your expenses on the go. Under the hood, we use sophisticated deep learning models to extract the details from your receipts and populate an expense report for you. The receipts themselves are stored in the data lake, and our data scientists use SageMaker and MXNet to train deep learning models on GPUs. Once the models are trained, we deploy them as RESTful web services in our data centers. We are excited about the potential of using ground truth now to label these receipts without having to leave our data centers, or without having to leave our secure ML environment on top of AWS. Our data scientists and engineers love the AWS tools. And as you can imagine, when you have data scientists and engineers being happy about the tools that they are using, this has resulted in increased productivity. And more importantly, fast experimentation. By leveraging SageMaker algorithms and GPUs, we have reduced the ML development time from months to weeks. My team is really excited and moving really fast. We are looking at a few other AWS services, particularly around the machine learning services, that are very interesting. As I mentioned earlier, we are evaluating ground truth to label data for our machine learning. There are other AWS services and SageMaker features that are of interest to us, like the elastic inference. And for some of the future use cases, we are looking at higher-level AWS services or AI services like Amazon Recognition. When I look to where we were about a year ago, we had a small team of data scientists and engineers with big ideas to transform the enterprise software. Using AWS and its full suite of services, we have built a secure and robust platform. And on top of that, we are building and delivering machine learning features to our customers. It has been an incredible journey, and we have only just begun. Thank you.
Thank you, Ellen. Pleasure. Great customer stories today. If I want to do a little bit of a recap here. So if I think about sort of modern application development, there's a number of areas that you really need to pay attention to. First of all, really thinking about sort of what are the new application architectural patterns, like serverless first. And really, modern applications are truly serverless, and we see really companies making the jump all the way from mainframe, immediately company leapfrogging all the way over to serverless. Really pay attention to what kind of data can you generate to both help your operational performance as well as your business performance, and what kind of information can you retrieve from that to build your next generation of products. And with all of that, I really want to emphasize that security is everyone's job. Because in the future, it's us as technologists that are responsible for protecting our customers and our business in that sense. Now, we're very fortunate over the past years to meet many of our extremely exciting customers. Whether those are young businesses or established enterprises that are going in completely new directions, we're very fortunate to meet with them. And one of the things that we've decided to do is to make a TV series out of it. Yeah, and so we have this long-form video content. It's called Now Go Build, where basically I visit young businesses around the world and do a deep dive on how these companies are actually truly changing the world around them. And so the first one that we launched during re:Invent was with a company from Jakarta called Hera Token, who's making use of blockchain technologies to build identities for the poorest farmers in Indonesia, such that they no longer need to go to loan sharks, which will charge them 20 to 60% on their small loans, but actually can really go to a bank because now they do have an identity. And actually, not only an identity, they have information about sort of the plot of land that they have, the yield, the growth, and things like that, really opening up the world of sort of government assistance and things like that for these youngest farmers. It's a great story. If you haven't seen that one yet, please go see it, because these guys are really changing the world for the poorest farmers in the world. Now, today we're actually releasing the second episode, where we go to Singapore, to a company called Simplistic. They made something called Roti-matic, sort of really changing the world that young Indian women have to live in by not having to continuously make food for their families and spend an hour and a half a day making rotis to eat with. Sort of really changing the world. And so they sold 40,000 of these machines, have AWS IoT integrated into it, and machine learning. But basically, you have a machine learning-driven roti maker. And new episodes from Norway and Germany and South Africa and Brazil will be released throughout all of this. Now, this one, the next one that's coming up, let's take a look at the trailer for Singapore.
Our planet and our civilizations are changing faster than ever before. This is Now Go Build. Join me as I travel the globe talking to startup founders, using technologies to make our world more interesting, accessible, and livable. These are the entrepreneurs that are creating the future we will live in.
So catch it on the YouTube channel. I think these stories are amazing. They're really fun. In this particular case, it's Simplistic, talking about sort of how does the kitchen of the future, a data-driven kitchen of the future using machine learning, looks like. So with all of that, thank you all for being here. I hope that the technical sessions this afternoon will really pique your interest, and that you go home knowing more about AWS than that you did when you walked in the door this morning. So thank you all, and go build.